Module 15, Spaces, Zones, Areas and Volumes. Welcome to Module 15 of the Revit for MEP training series. In this session, we're taking a deep dive into one of the most powerful analytical features in Revit: spaces, zones, areas and volumes. These tools form the backbone of early-stage building services design, allowing us to define usable areas, calculate volumes, assign environmental data, and prepare models for energy analysis. By the end of this module, you'll understand how these elements behave, how they interact with the model, and how to use them to extract meaningful design information. Section 1. Understanding the terminology. Before we begin modeling, it's important to clarify the terminology. Revit uses 4 closely related concepts: rooms, areas, spaces, and zones. And although the names sound similar, each one serves a very different purpose. Rooms belong to the architectural workflow. They represent habitable spaces and store information like finishes, occupancy, and usage. They also provide floor area, perimeter, and volume data. Areas are also architectural, but they work at a broader level. They're used in area plans to analyze departments, circulation ratios, rentable space, or apartment sizes. Spaces, however, are the MEP equivalent of rooms. They use the same bounding elements, but they store mechanical and electrical data, things like air change rates, temperature, humidity, lighting loads, and power density. Spaces are essential for HVAC sizing and energy analysis. Finally, zones group multiple spaces together. A zone might represent all the rooms served by a single air handling unit, or a group of spaces that share the same environmental conditions. Zones are critical for heating and cooling load calculations. Section 2. How spaces work. A space isn't created by drawing walls, it's placed into an enclosed region of the model. Revit automatically detects the bounding elements around it: walls, floors, ceilings, roofs, columns, curtain systems, and separation lines. If you imagine pouring water into a room, the water would spread until it hits a boundary. That's exactly how Revit defines a space. Openings created by hosted elements like doors and windows don't break the boundary. But if a wall is physically split or its profile is edited, the space can spill into adjacent areas unless a space separator is used. If 2 spaces accidentally occupy the same region, Revit warns you and marks one as a redundant space. This prevents double counting in schedules. Section 3. Space data and analysis settings. Spaces carry a huge amount of analytical data. Revit includes predefined space type settings that automatically populate heating, cooling, occupancy, lighting loads, and power loads based on typical usage. For example, an office, a classroom, or a hotel dining room. Construction type settings allow you to override the thermal properties of walls, floors, roofs, and windows. These values form the basis of U-values and solar gain calculations. This data becomes essential when preparing the model for energy analysis, whether using Autodesk's cloud tools or exporting to third-party software. Section 4. Space tags and schedules. When you place a space, Revit automatically adds a space tag. But the tag and the space are separate objects. A space can exist without a tag, and a tag can appear multiple times in different views. Tags can display any parameter you choose: name, number, area, airflow, lighting load, or even custom shared parameters. Space schedules are one of the most powerful tools in this workflow. They allow you to review area, volume, and perimeter, edit space data directly, predefine spaces before placing them, remove or reassign spaces, cross-reference space data with other categories like air terminals. Any change made in a schedule updates the model instantly. Section 5. Area and volume calculation. Revit calculates area and volume based on the calculation height. Rooms default to 1,200 mm, while spaces default to 0 mm. Raising the calculation height can exclude sloped areas, which may be appropriate for architectural regulations, but not for mechanical analysis. For accurate volume calculations, the upper limit of the space must extend above the highest bounding element. If volume computation is disabled for performance reasons, it must be re-enabled before running energy analysis. Section 6. Zones and energy settings. Zones allow you to group spaces that share environmental conditions. They can span multiple levels and include plenums or risers. Zones are tagged using the standard tag by category tool and scheduled like any other element. Energy settings define the overall analytical model: building type, location, infiltration class, glazing percentage, and sliver space tolerance. These settings ensure that the exported energy model is complete and free of gaps. Section 7. Area schemes and colour schemes. Area schemes allow you to analyse a building based on different criteria: gross internal area, gross building area, or rentable area. These schemes help visualise how space is allocated across the project. Colour schemes bring your data to life. You can colour fill views based on rooms, spaces, zones, or areas, using any parameter: usage, department, airflow, temperature, or even custom values. This is a powerful way to communicate design intent and analysis results. Exercise. Now let's move into the practical exercise for this module. In this exercise, we'll work with spaces, zones, and colour schemes to understand how Revit manages building services data. You'll begin by placing spaces into the model, ensuring that each enclosed region is correctly identified. You'll review the bounding elements, adjust space properties, and verify that the calculation height and upper limits are set correctly. Next, you'll create a space schedule to review the areas and volumes. You'll modify space names and numbers, adjust environmental data, and ensure that all spaces are accounted for, including plenums and risers. You'll then create HVAC zones, grouping spaces served by the same equipment. You'll assign zone properties, tag the zones, and generate a zone schedule to confirm the grouping. Finally, you'll apply a colour scheme to the floor plan. You'll choose a parameter, such as space type, department, or airflow, and apply a colour fill legend to visually communicate the data across the model. By the end of the exercise, you'll have a fully coordinated set of spaces and zones, complete with schedules and colour-filled views, ready for analysis and documentation. Step 1. Start by opening the starter file called WFP-RME-15-spaces-A. Once it's open, navigate to the 0 mech floor plan and open that view. This is where we'll be placing and managing our spaces. Step 2. Go to the Analyze tab on the ribbon. In the Spaces and Zones panel, click on Space. This activates the Space Placement tool. Step 3. Look at the options for the Space tool. Make sure Tag on Placement is turned on in the contextual menu. This ensures that every time you place a space, a tag is automatically created at the same time. Step 4. Now check the options bar at the top. Set the upper limit to first floor with an offset of 0.0. Set the tag placement to horizontal. Make sure the leader checkbox is off. And in the space drop-down, make sure New is selected. These settings control how the space volume is defined and how the tag appears. You'll notice that any spaces already placed in the model appear in a pale green shade with a diagonal cross. That makes it easy to see which rooms already have spaces and which ones still need them. Step 5. Now, click in the center of each remaining room to place spaces. Follow the numbered order shown in the exercise image if you have it, but don't worry. If you don't click in exactly that order, the exercise will still work. The key thing is that every remaining room gets a space. Once the spaces are placed, we'll start editing their information in different ways. Modifying space properties directly. Step 6. Move your cursor around inside the room marked 1 in the exercise diagram. You're looking for a diagonal crosshair to appear. This indicates the actual space element, not just the tag. When you see that crosshair, click to select the space. Step 7. With the space selected, look at the Properties palette. Change the name of this space to Conference Room. Check that the number is set to 0 to 11. Now repeat this for the room marked 2. Set its number to 0 to 12 and its name to Technical Support. Modifying space properties via the tag. Step 8. Next, click on the space tag in the corridor marked 3 in the diagram. This time, don't select the crosshair. Select the tag text itself. Click first on the number and change it to 0 to 13. Then click on the name and change it to Circulation. You're editing the same underlying space, but this time through the tag. Be careful not to double-click the tag as a whole. That would open the tag family in the Family Editor. If that happens, just close that window and return to the project. Step 9. Use the same tag editing method on the room marked 4. Change its number to 0 to 14 and its name to Sales Office. Modifying space properties via the schedule. Step 10. Now we'll switch to working through a schedule. In the project browser, under Schedules/Quantities, open Space Schedule. Step 11. Go to the View tab, then the Windows panel and choose Tile. Arrange the windows so you can see both the space schedule and the 0. Mech floor plan at the same time. You should be able to see the remaining unnamed spaces. These are spaces 5, 6 and 7 from the earlier diagram. Step 12. Click on any space row in the schedule. You'll see the corresponding space highlight in the floor plan. This is a great way to cross-check which schedule row belongs to which physical space. Step 13. Now, in the schedule, find the rows for spaces 0 to 15, 0 to 16 and 0 to 17. These correspond to the remaining unnamed spaces. Change their details as follows. 0 to 15 to name Sales Office. Zero to 16. Name Training Room. Zero to 17. Name Training Room. You can either type the names directly or pick from the drop-down list in the name column. Step 14, still in the schedule, go to the space type column for these new spaces. Choose appropriate space types from the drop-down list. For example, office type or training type descriptions. The exact choices aren't critical for this exercise, but in real projects they drive default environmental and energy values. Working with zones now, we'll move on to zones, which group spaces for shared environmental control. Step 15. On the ground floor, move your cursor around spaces 0 to 1, 0 to 2 and 0 to 3 until Revit lets you select the zone that already connects these three spaces. You're not selecting the spaces themselves, but the zone that groups them. Step 16. With that zone selected, look at the ribbon. On the Modify/HVAC Zones tab, click Edit Zone. Step 17. In the Edit Zone mode, add space 0 to 6 door to this zone. You can do this by selecting it from the list of available spaces in the zone editor. Step 18. Click Finish Editing Zone to confirm the changes. Step 19. Repeat the same process for the zone that links the entrance and the existing circulation corridor. Edit that zone and add the circulation space 0 to 13 to it. Finish editing when you're done. Creating a new zone from selected spaces. Step 20. Now we'll create a brand new zone for the remaining spaces. Hold down the Control key and select each of these spaces. 0 to 11, 0 to 12, 0 to 14, 0 to 15, 0 to 16, and 0 to 17. You should have 6 spaces selected at once. Step 21. With those spaces still selected, go to the Analyze tab, Spaces and Zones panel, and click Zone. Revit will create a new zone and automatically add all the selected spaces into it. Room, Space, Separator Lines. Now we'll look at using space separator lines to subdivide a large open plan area. Step 22. Navigate to the MEC floor plan. Zoom into the large open plan room on the left, labelled 1-1. Step 23. Select the existing space in this room, Office 1-1, and delete it. Make sure you delete both the space and its tag, not just the tag. You'll get a warning that the space still exists in the project but is no longer placed in the model. That's fine for now. Step 24, go back to the Analyze tab, Spaces and Zones panel, and this time choose Space Separator. This tool lets you draw theoretical boundaries without adding physical walls. Step 25, using space separator lines, sketch a new region in the top right corner of Office 1-1. The exact size isn't important. Just create a smaller corner area within the larger room. Step 26. Now select the Space tool again. On the Options bar, where the space is currently set to New, open the drop-down and choose 1-1 Office instead. This tells Revit you want to reuse the existing unplaced space 1-1 Office. Step 28. Then place a new space into the smaller corner area you defined with the separator lines. Step 29. Select this new space and rename it to 1-13, breakout space. Step 30. Now edit the zone that links the first floor offices. Add both the 1-1 office space and the new breakout space into that zone. Finish editing the zone when you're done. Applying a color scheme. Now we'll use color schemes to visually show which spaces belong to which zones. Step 31. Reopen the 0. Mech floor plan if it isn't already active. Step 32. With the plan view active, look at the Properties palette, find the color scheme field and click in the box next to it. This opens the Edit Color Scheme dialog. Step 33. In the top left of the Edit Color Scheme dialog, set the category to HVAC zones. This tells Revit we want to color the view based on zone information. Step 34. From the list of available schemes, choose Schema 1. You'll see a table listing the zone names and the colors assigned to each. Step 35. Click OK to apply the color scheme to the plan. The spaces will now be color-filled according to their zone. Adding a color fill legend, Step 36. To explain the colors on the drawing, we'll add a legend. Go to the Annotate tab, and in the Color Fill panel, click Color Fill Legend. Step 37. Move your cursor over the plan and click to place the color scheme legend in a suitable location. This legend lists each zone and shows the color associated with it, making the drawing easy to read and interpret. And that concludes Module 15, Spaces, Zones, Areas and Volumes. You've now seen how Revit defines enclosed regions, how spaces store mechanical and electrical data, and how zones bring those spaces together for environmental analysis. You've also learned how to calculate areas and volumes, how to schedule and tag spaces, and how to use color schemes to communicate design intent. These tools are essential for early-stage design, energy modeling, and coordinated MEP workflows. Thanks for watching, and I'll see you in Module 16, where we'll be focusing on 2D drafting and annotation.